Bonjour à toutes et à tous. Hello. I'm very honored and pleasure to be here today to talk to you about brains and interfaces. So my name is Celia Hodent. I have a PhD in psychology, and I'm specialized in cognitive development. And for the past 10 years, I've worked in the video game industry at Ubisoft, at LucasArts, I work on Star Wars games, and Epic Games, where I was the director of user experience at the studio level, and I worked a lot on a game called Fortnite that you might have heard of. Now I'm a game UX consultant, helping game studios of all sizes create games that will offer a great experience to their audience. So what is UX? What does user experience mean? When we design something, whether it's a park, an object, a video game, a website, a service, we design the environment, but we can't design the experience because the experience happens in the user's mind. Like in this example, if users decide they want to reach a certain goal faster, they will use the environment the way they see fit. So designers need to design the environment in such a way to fit their users' needs and expectations, but also to fit human brain limitations. For example, take a look at this. The human brain is not good at scanning quickly an environment to find what it needs. And if it takes you more than 2 seconds to figure out on which button to press to reach a certain floor in an elevator, then it means that the design was not thought through to make it easy for the user to accomplish their goals with the system. So this interface is not really intuitive. It takes too much time to comprehend, and in our jargon we call that UX fail. So every time we struggle to figure out how something works, it means that the product has UX issues. It doesn't work intuitively, and it can be extremely frustrating. What we want is products that are intuitive to use, just like a door with a plate on one side, so it affords you to push, and a handle on the other side, so it forces you to grab the handle and pull. So you don't even have to read words about push or pull, you just know by looking at it what you need to do with the system. So this is what user experience is. It's about considering human factors when we design objects, systems, or services. We also call it human-centered design. How do we do that? So people like me help developers understand how the brain works and understand its limitation. So what does it mean? Whenever you use an interface, whenever you learn about something, this is the process that happens. So it all starts with perception, it starts with an input, and through the processing, through the learning, in the end it's going to change something in your memory. Physically, it's going to change the synaptic connections in your brain. So, of course, a lot of factors are going to influence this learning process. Among these factors, there's emotion, motivation, attention, there's biological factors as well. But here today, I'm going to talk very briefly about perception, memory, and attention. Just quick disclaimer, this is a very oversimplified diagram of how the brain works. It doesn't work in independent buckets. We don't have only 5 senses, by the way. It's everything. It's not serial. It's not even a process like a process for a computer, because the brain does not work like a computer. But it's just for the sake of the explanation today. So we're going to take an example for perception, memory, and attention to explain what we mean by limitations. Perception is subjective. For example, it depends on context. Here, the input at the center, you might perceive it as a B. But if I add this, you might perceive it as a 13 now. So perception really depends on the context, and it's subjective. Look at this one. You can either see a duck or a rabbit. So it's unstable. What about this one? So usually I show that to game developers, and they see specifically immediately when I show them that a lot of people see Street Fighter characters. So I don't know if you ever played that game, but for the people who played that game, it's it pops immediately in their mind. They recognize these characters because they played that game a lot. And if you never played that game, you're like, what is this? It's just like Call the Stripes, I don't get it. And if you are colorblind, there's about 8% of the population, the May population, who has some sort of color blindness. You hate me right now because you feel left out by this slide, and I apologize for that. So perception is subjective, and our cognition, our prior knowledge, our expectations, what we know about the world, what games we played before is going to influence our perception. So our perception is subjective. Even though it seems obvious to us, and a large area of the brain is dedicated to it. And a memory is not very reliable either. This is what we call the forgetting curve, made by Hermann Embigos back in the 19th century. It's illustrating the exponential nature of forgetting. So this is like the worst case scenario when you learn something that's not meaningful to you, that you don't care about, with no methodology of any kind. When you do that, after just a day, you're going to lose about 70% of the content that you learned the day before. So let's play a little game here to see how's your memory, is it fit? Try to visualize in your mind the thinker, le penseur, d'Auguste Rodin. Can you remember on which leg or legs lay which arm or arms of the thinker? Can you think a little bit about it? This is where sometimes I spot people do that to try to remember how it works. All right, let's take a look at the answer. All right, so did you remember that perfectly? Most of us don't, because we just have an approximate remembering of that sculpture. Now, if you're an artist and you spend time copying this piece of art, or you redid the sculpture for yourself, you might have a much better memory of it. But for most of us, it's pretty inaccurate. And in fact, we often remember things only approximately, and we also can fabricate false memories. So our memory is fallible. All right, let's do another little game here. I'm going to show you some cards, and I'm going to ask you to pick a card and to remember that card. All right, pick a card. All right, I bet I can guess which card you picked and make it disappear. Did it disappear? Yes, I've changed all the cards. This is called change blindness, and it's very well known in psychology. And as a matter of fact, magicians, this is how they do their trick. They trick our perception, they trick our memory, and they trick our attention. They ask us to look here, and they do something here. They're very good at that, misdirecting our attention. So change blindness is the failure to notice about an obvious change. You might have heard of this experiment. It's the invisible gorilla effect. It's a study by Simons. People need to count the basketball passes the team in white make, and they miss a person in a gorilla suit because we're focused on the task. We don't see that the gorilla is there, and it's very, very stunning for us when we look back at the video and we see the gorilla. Like, how did I not see that? And that's the problem. When we're really focused on something, it's really hard to pay attention to something else. So our attention is very limited. Perception is subjective, memory is fallible, and attention is limited. So what do we do with that when we design environments? Well, we have some guidelines that we can use, knowing these brain limitations. So this is what designers can do. It's like a checklist to ensure that the product is going to be usable in the end. In case of video games, we also want the game to be fun and engaging. So we also look at motivation, emotion, stuff like that. So I'm not going to talk about that too long. But we ensure, for example, that information in the game, what we call signs and feedback, are going to be clear and consistent. And we try to keep the player in a flow, when the game is never too easy or too hard, so people can enjoy themselves. And what we do also is we regularly conduct some play tests in UX labs. We watch players from our audience who've never played the game, so we can see where they're having issues. So we test the game to make it better. Since it's so hard to design interfaces that are intuitive and provide great experiences, not having an interface sounds like a win for everyone, right? But what does zero interface mean, really? Is there such a thing as no interface at all? So here's an example that I particularly like. It's a Mind Light. It's a mind control game to help children with anxiety. So the kids need to concentrate and calm down to turn this light on in an environment, and so it's lighting up the room and chasing away the monsters. One of the developers, Isabella Granek, is showing off the device here. So you see, we have an interface in that case, and it requires players' concentration to make it work. The device is not precise, but it's just good enough to make the magic work. So all this zero interface take is very promising, but it's either non-invasive, like this one, and extremely limited, or it is invasive. We have implants in our brains, and it's still very limited, and it requires a lot of attention, it requires training, etc. So it makes total sense for health purposes to spend a lot of time training to make it work, but not so much for entertainment. So it's not really that we're moving towards zero interface, rather we are moving from human-computer interfaces to brain-computer interfaces. The problem is that the brain is quite complex, much more than anticipating human behavior. We barely understand how the brain works. In fact, the human brain is so limited that it's not good enough to understand itself. We're going to have to get the help of AI to figure it out. So as compelling as brain-computer interfaces sound, we won't solve design issues anytime soon. We'll still need to figure this out. And if BCI have clear advantages regarding health, removing steps between humans and systems could potentially be harmful. So let me explain that with a little game. Try to answer this question as fast as you can. A bat and a ball cost $1.10 total. The bat costs $1 more than the ball. How much does the ball cost? I'm not going to let you think too much about this one. So the ball costs 5 cents. Most of you maybe thought that the ball costs 10 cents. That's because we get tricked by just the sentence. But if you do the math, it doesn't work. So this puzzle was part of the cognitive reflection test by Shane Frederick in 2005. And 83% of MIT students answered wrongly to at least one question. There were several questions, and at least one of them they got it wrong at 83% of the time. And we make these mistakes not because we lack logical skills, but because it's less costly for the brain to use shortcuts. Our brain is just lazy like that. The brain is extremely good at very quickly making sense of the world with little information. That's how we survived our predator. So all the mistakes the brain makes are insignificant trade-offs in the scale of evolution. However, we need to be aware of our limitation of these biases to avoid being manipulated and to build a fairer society. So Daniel Kahneman, a psychologist who received the Nobel Prize in economics, explains that the brain has two systems. You have system 1, that is fast and prone to biases, and you have system 2, that is slow, controlled, and effortful. So when we answer 10 cents to the previous game without too much thinking about it, we rely on system 1. It's just automatically finding the answer. But the problem is that this system is heavily biased. And system 2, that is more controlled, could actually find the answer, might not be aware that this is going on, that something is wrong. This is the chart of most of our cognitive biases, which you can find on Wikipedia. We believe we have an accurate perception, that we have an accurate memory, that we can multitask. We believe that we're in full control of our decisions, that we have free will, that we can understand others, that we are logical beings. This is all a lie, okay? So don't think you can make the most logical and efficient decisions most of the time, because you don't. And don't assume others are making irrational decisions because you believe they're dumb. We all have limited capacities to reason rationally, and we're mostly unaware of this. So the thing is that people can take advantage of our system 1, our biases, to trick us in making a decision more beneficial to them. This is an example described by Darren Ariely in his book, Predictably Irrational. He saw an advertisement for a subscription to a magazine, and there were 3 options. You could get either the web subscription only for $59, or the print subscription only for $125, or you could get print and web subscription for $125. So he wondered why you would pick the print subscription only for the same price as the print and web. So what he did is, because he was in a university and a professor there, he just used these options and asked students what they would pick. Well, in that case, most of the students are picking the print and web subscription at 84%, and no one is choosing the print subscription only. So he thought, okay, what happens if you just remove that option? Because it's useless, no one is picking it. So he took other students and asked them the same question, which one between these two would you pick? Well, in that case, it's the web subscription only, that's the cheaper, that people pick. So this is called the Decoy effect, and it explains that most of the time we're not making rational decisions. Our decisions mostly depend on the context, and here, because we have a decoy that looks less interesting, it makes us buy the higher price. If I use my knowledge in psychology and cognitive biases to make you believe that, as it's often the case, buying a 12-month subscription is more interesting financially than buying a month-to-month subscription, pro tip here, the one on the right is actually $1.11 more expensive than the one you pay month to month. That happens. I saw that for real. I'm not naming anyone, but I saw it for real. So this is what we call dark patterns in UX. It's using tricks like magicians not to entertain you, but to deliberately take advantage of you. Here's an example that you might have seen. So here, you can be tricked in signing up to Amazon Prime because you just want to click to the big orange button, you think you just continue with the purchase, and you might not see the opt-out button that is super tiny and hard to perceive. Here's another example that's quite interesting as well. It's quite creative. It's faking that there's a hair on your phone, so you swipe up to get rid of the hair, but it's actually making you go to the shopping screen. So you can check, if you're interested in these creepy dark patterns, you can go check this website. It's quite interesting. But when is it a dark pattern and when is it just good UX? Because this screen is deliberately making it harder for you to delete an avatar that you spend hours, days, or even months to play with. This is coming from World of Warcraft. So your characters is that avatar, and you develop that avatar for many, many hours. So in this case, we add a friction, so you're not going to delete that avatar by mistake. So it could be considered as a dark pattern, and actually it's here to help you out. So manipulating the environment to make people behave in certain ways is not necessarily bad. Road safety measures, for example, or encouraging people to save power or recycle are all very important things. The problem lies in identifying what are the end goals and defining if these goals are for the greater good or not so much, because we always design the environment to make people behave in certain ways. So we need to have a public debate on ethics in tech, and we probably also need to teach people about cognitive biases, adults and kids alike. As Kahneman put it, intelligence is not only the ability to reason, it's also the ability to find relevant material in memory and to deploy attention when needed. So it could be beneficial to individuals and democracies to encourage people to recognize biases and stop and think before getting tricked into doing something irrational. In a series of research conducted by Michel and known as the marshmallow test, 4-year-olds are given a choice. They can either have one marshmallow now and eat it, or wait for 15 minutes, just not doing anything, just in front of the marshmallow, and then they get 2 marshmallows and they can eat it. It's called delaying gratification, and as you can see on these pictures, it's quite difficult for 4-year-olds to not eat the marshmallow. But children who had shown more self-control at 4-year-olds had higher scores on tests of intelligence later on. Resistors had higher measures of executive control in cognitive tasks. As young adults, they were less likely to take drugs as well. Correlation is not causation, and we have to keep that in mind. But attention, we know that it can be trained through video games. We can think of could we train ourselves to pay more attention, to stop and think before making a decision? So maybe we could do that, and we can train ourselves to not fall prey for biases, although it's always easier to do that for others than for ourselves. So maybe AI could help us fight biases. Let's take the example of autonomous cars. They should be safer to use because AI is less fallible than humans, right? The problem is that autonomous cars are not capable of functioning without human intervention yet. And humans driving these cars are under the false impression that they can lower their attention. So until cars are completely autonomous and all vehicles are driven by AIs, these cars are deceiving. And car makers cannot blame it on humans behind the wheel when there's an accident. We know that humans have biases. Designers know that. So if designers don't design with human factors in mind, then they are responsible for human mistakes. Here's another example, a bit different, this time illustrating how AI, instead of being free from human biases, feed on them. So in Turkish, you don't have gender like you have in French or in English. So if you want to translate, he is a doctor or she is a doctor, you will get the same phrase, which I'm not going to pronounce because I don't speak Turkish, but you have the same thing. There's no gender in Turkish. What if you just pick the phrase in Turkish and Google translate it in English? Well, surprise, here you have the gender, male gender, he is a doctor. And now if you do it with nurse, so the Turkish word for nurse, you get she is a nurse. So this is how gender bias is perpetuated by AI. Algorithms favor information that is popular, no matter if true or false. This is a real Google search that I did with vaccines, and their impact is becoming very concerning. Fake news have always existed, for sure, but it has dramatically increased lately. This is the Facebook engagement for top election stories. You see that fake news is going over mainstream news. And it's becoming a real concerning issue affecting our democracies now. And it's mainly because some designs specifically trick our system when most of us don't stop and think before clicking. All is done in the design to encourage us to click. As a matter of fact, we call that clickbait. And bots, picked up by algorithms, spread the bullshit even faster. All right, so one last thing that creeps me out is that even if you're trained in recognizing dark patterns and cognitive biases, it's becoming harder to discriminate fake from real. So this video that I want to show you, it's a tool created by a team at the University of Washington, allowing to lip sync an Obama video using any audio.
Here's an older Obama speaking his words from a quarter-century ago.
Although I'm honored, I think people can say that my election symbolizes some progress, at least within the small confines of the legal community.
We can even create an Obama video from voice impressionists.
Here we go. President Barack Obama. When you're giving a speech, make sure you use a lot of pauses and speak in a very weird timbre. Up and down and up, down, down.
It's funny, but it's quite creepy as well. Technology makes it easier to design manipulative environments. Brain-computer interfaces are fascinating, and they could be very promising, but they could also make it even harder for us to be able to stop and think before making a bad decision. So how much control do we want to give away to AI? AI is not a magic trick that will solve everything. It feeds on our biases and can potentially make the impact of these biases worse. The danger does not lie in technology by itself. It lies in the environments that we design with it. So we really need to have a debate about ethics. So I hope that your system too enjoyed this presentation, and I thank you very much for your attention.